Assalamu alaikum dear students, how are you all? Hope you will be fine and enjoying good health. Let's start our today's topic, ionization energy and trends. Previously we discussed about the shielding effect and atomic size or radius, and we know that atomic size along the period decreases and along the group increases. The reason is that number of shells remain the same in the period, and effective nuclear charge increases, and in the group it's opposite. The atomic sizes increases because of the more number of shells and poor shielding effect. And next we will discuss about the ionization energy. And ionization energy, what is the ionization energy? And it is the amount of energy required to remove the most loosely bound electron from an isolated gaseous atom. For example, we take an atom in its gaseous state and single atom, and we will remove electron from its outer shell by providing energy. Because why it is easy to remove the electron from the outer shell? Due to the shielding effect, the nuclear charge, the effective nuclear charge which reaches towards the outer shell is less, and outer shell electrons are not tightly bound and not more strongly attracted towards the nucleus. That's why it is somewhat easy to remove electron from the isolated gaseous atom. So ionization energy is the amount of energy required to remove electron from the outer shell of an atom. And you can see that here is the example of an atom in which it contains 2 electrons in its K shell and 4 electrons in its outer shell. It means it have total 6 electrons. I think it's the atom of the carbon atom, which has 2 electrons in K shell and 4 electrons in outer shell. And to remove the electron from the outer shell, the energy which is required is called ionization energy. And ionization energy also opposite to the atomic size or radius. Ionization energy increases from left to right in a period and decreases moving top to bottom down a group. Why it increases and why it decreases, we will discuss in detail. As we know that first of all, there is a definition. Then ionization energy is the amount of energy required to remove the most loosely bound electron from the valence shell of an isolated gaseous atom. And listen girls, there are more than one ionization energies. We know that first group elements contain 1 electron in their outer shell, second group contain 2 electrons, and third group contain 3 electrons in their outer shell. All these are metals, and they also tend to lose electrons and gain positive charge. So when we move electron from the first group elements, because they have 1 electron, the ionization energy will be called first ionization energy. And when we move from the electron from the second group, they have 2 electron in their outer shell, and we can't remove 2 electron at a time. So we remove electron one by one by providing more and more energy. And that's why second group elements show 2 ionization energy, first and second, and third group elements show 3 ionization energy, first, second, and third. And first ionization energy is always less than the second ionization energy is more than first ionization energy. The reason is that after removing electron from the isolated gaseous atom, the ratio of number of electron and number of proton will be disturbed. There will be more proton than the electron. For example, if we remove electron from the sodium atom, here it is the example, we require 496 kilojoule per mole energy. And when we remove electron from the magnesium, because it has 2 levels, it belongs to second group, and it has first ionization energy and second ionization energy, but the amount of second ionization energy is more than the first ionization energy. The reason is that when we remove 1 electron, the number of proton will be increases and number of electron decreases. That's why the hold of nucleus over the outer electrons will be increased. That's why there will be difficulty for to removal second electron from the outer shell when we remove first electron from the second group elements. So similarly with the third group elements, when we remove first electron, it will require less energy, and when we remove second electron, it require double amount of energy, and when we remove third electron, it will require triple amount of energy, because of by removing electron, positive charges increases and nucleus will attract the electrons towards itself more strongly. So first, here is a heading. First heading is ionization energy. Ionization energy definition, and second heading is first ionization energy. The amount of energy needed to remove successive electron present in an atom increases if there is only one electron in the valence shell. The energy required to remove it will be called first ionization energy. And next heading is example, which is still 496 kilojoule per mole. Kilojoule is the unit, and per mole is mean 1 mole of the atom. When we take 1 mole of the atom, the energy will be released in the form of kilojoule, which is 496. And we'll because energy is required, we add the energy. Delta H is the change in energy, change in enthalpy, and because this amount of energy required, not I mistakenly said that release, not release, it is required to remove most loosely bound electron from the isolated. That's why we add the energy, and the plus sign indicate that we are adding the energy. Next, delta H is the change in enthalpy. Next, the second paragraph heading is second and third ionization energy, and this heading is starting from here. But when there are more than one electron in the valence shell, they can be removed by one, providing more and more energy, such as group 2 and 3 elements have more than one electrons in their shell. Therefore they will have more than one ionization energy values. And next we will discuss the trend. Main heading is trend of ionization in periodic table, and subheading is trend in period. Trend in period starting from here. If we move from left to right in a period, the value of ionization energy increases. This is the trend. And after that, the second subheading is reason. It is because what is the reason why the ionization energy increases? Because we know that it is related to the atomic size. Atomic size decreases. Why? Because atomic size decreases, and there will be more attraction between the nucleus and outer shell electrons. That's why it will be difficult to remove electron from the outer shell. That's why then when the atomic size decreases from to left to right in the period, ionization energy increases, because it will be difficult to remove electron from the outermost shell of an isolated gaseous atom when we move from left to right, because there is increase of effective nuclear charge, and there is a more force of attraction between the nucleus and outer electrons. Next, therefore elements in left side of the periodic table have low ionization energy as compared to those on the right side of the periodic table. Left side, we know that left side elements like lithium, beryllium, boron have low ionization energy, and right side is the fluorine and neon has more ionization energies, because the size of their increased force of attraction, and electrostatic force of nucleus mean the force of attraction which exists between the opposite charges. For example, positive charge on the nucleus and the negative charge on the electrons, which attract each other. Next, trend is trend in group, and here to write trend, which is given as trend in group subheading. It decreases from top to bottom in a group. You have to add this line here. After that is the reason. As we move from down the group, more and more shells lies between the shells and the nucleus of the atom. These additional shells reduce the electrostatic force felt by the electrons present in the outermost shell. Because we know, as you can see here, lithium has 3 atomic number. It has 3 electron proton. Sodium have it has 2 main shell, K or L. Sodium has also 2 3 main shell, potassium 3 main shell, rubidium 4, and cesium 5. Similarly, the number of shell increases when we move from top to bottom in a group. The number of shell increases, the radius, the distance of the outer shell electrons and the nucleus also increases, and due to the presence of inner electrons, more shells, number of shell increases, distance increases, distance between the nucleus and the outer shell increases, and the effective nuclear charge or shielding effect also increases, and effective nuclear charge reduces, remain the that's why resultant valence electrons taken away easily can be removed easily from the outer shell due to the increase of number shells and number of inner electrons. The charge of the nucleus felt by outer shell electron will be less, and there will be there will be easy to remove the electron from the outermost shell. So it is the long question of the exercise. Long question 8, and next we will discuss long question 9, electron affinity, in our next lecture. Till then, Allah Hafiz. And here is the more explanation of trend of the ionization energy in the groups. For example, lithium require 519 kilojoule per mole. Value increases down the group. Despite an increase in equal charge, the outer electron is easier to remove. This is due to the increased shielding and greater distance from the nucleus. There are the two reasons why the ionization energy decreases in the group, because the distance between the nucleus and outer shell electron increases, greater distance and more shielding effect. And the trend in the period is opposite to the group, because in the period size decreases, the distance between the nucleus and outer shell electrons also decreases. That's why outer shell electrons are strongly attracted by the nucleus, by nuclear charge and electrostatic force of nucleus. That's why it will be difficult to remove electron from the outer shell, and ionization energy will increases. So in this today's lecture we studied about the definition of ionization energy. The summary of the today's lecture is that first we learn about the definition, which is the amount of energy required to remove the most loosely bound electron from the isolated gaseous atom, single atom in its gaseous form. Second, we discussed about the first, second, and third ionization energy, which is increases when we remove electron 1, 2, 3, and 4 electron, 1, 2, or 3 electron till 3 electron. Next, we discuss the trend in the periodic table, and ionization energy increases left to right in the period because of decrease of distance of the outer shell electrons and between the nucleus, and also due to the increased force of attraction, the size decreases, and it will be difficult to remove electron from the outer shell, and it decreases in the group. Ionization energy decreases in that group, and it will be easy to remove electron from the outer shell because of more number of shells and greater distance and increased shielding effect. So that's all. Thank you for watching. Next we will discuss long question 9. Till then, Allah Hafiz.